Okay, I'll do angle A first. All right, to bisect angle A. Now remember what an angle bisector does. It cuts it in half. I'm going to make two congruent angles on each side of it. So everyone put your compass point on A or B, depending on what you're going to bisect first. Make an arc through angle A or B. So it intersects in two spots. From here, depending on how you feel with your compass right now, you can open or close your compass, but just make sure the next two arc marks are made with the same opening. Okay, make sure they're going to be made with the same opening. All right, so go to each point of intersection right now. Go to each point of intersection on your triangle and make two more arc marks below or next to the ones you just did. But you got to make sure these last two arc marks intersect. So go to each point, make sure they intersect. And then you guys can grab your straight edge and draw in your angle bisector. And when you're done, put some, we're on week 12 right now together in honors geometry. Week 12, can we put congruent marks on each side right now? Show me the angles are equal. Because that tells me you're doing, even if I had no idea how to do this construction, if I saw these arc marks on your diagram, I at least know you bisected the angle. All right, let's do it for the other angle, whether it be B or A. Let's do the same thing. Put your compass point on the vertex of the angle you're copying, or bisecting, excuse me. Make your arc mark through again. You can keep your compass opening the same. Open it up, close it, but make sure the last two arc marks are the same opening. Draw in your angle bisector, make a couple arc marks for me on each side like usual. And I really didn't feel like doing the third angle and doing the bisector and getting this whole mess on your paper, because I know some of you may have struggled with just those two. But if I made an angle bisector from C, predictions, what would happen? If I had you go ahead and do angle C right now, what would predictions be? Radhika, what's your prediction? What would happen with my angle bisector from C?
They would all meet at the same point.
They would all meet at the same point. They would be, what's the big boy, big girl word? Concurrent. They would be concurrent. Correct. So there's your conclusion right now. All three angle bisectors in a triangle. All three angle bisectors in a triangle are, what's the vocabulary term we're using nowadays that say they all intersect? Are concurrent. Everyone at home all right with that? So now you have two sets of lines that you know are concurrent. Angle bisectors, and what'd you learn on the Ed Puzzle video that are also concurrent? Perpendicular bisectors. Good, good. Everyone with me so far? I want to make sure I'm slow on the explanation. All right, everyone mark the point where they're concurrent at. Mark the point of concurrency, please, on your construction. I'm sure you know, probably guess, it's got a special name, right? It's got a special name. Perpendicular bisectors, we called it the circumcenter. For the angle bisectors, everyone ready? It's called the incenter. 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 Okay, so the angle bisectors intersect at a place called the incenter. What's so special about it? Here you go. Here's what's special about it. What was special about my circumcenter? Equidistant from the vertices, right? Incenter, equidistant from the sides. Not the vertices, from the sides of the triangle. Everyone take a look at my diagram triangle ABC down below here. Okay? I am going to tell you that D is the incenter. Okay? D is the incenter up here. It is equidistant from the sides. The sides. And how can I tell where on the sides? Take a quick look here. It should be the perpendicular distance to the side. So you should see right angles. Okay, because it can't be equal to any point on the side. It's got to be the point on the side where it makes a right angle. Okay, so the incenter is equidistant from the sides. So my conclusion here about my diagram, here's what I can conclude. So I'm sitting there and I say, oh, D's the incenter. Okay, that's equidistant from the sides. So name a line somebody name a line segment that goes from the incenter to the side of the triangle. Just name one of the three that are up there. ED. So I know that distance, that line segment, ED, is congruent to FD, which is also congruent to GD. Okay, everyone see how the incenter works? Equidistant from the sides. And when we say the sides, it's got to be that perpendicular distance from the sides. And the diagram will always have right angles in there for you. Anything you'd like to ask about the incenter? Go to the front of your
What does this have to do with perpendicular lines?
Say that again?
I'm confused what this has to do
Okay,
with.
yep, here you go.
Lines.
Here's the deal. Say this is my incenter right here. I'll just call it I for incenter, right? You know it's equidistant from the sides. That's the rule about the incenter, right? But here's the thing. That's not going to, if I draw it here to the side and here to this side, there's no way those are the same distance. Everyone agrees? No way. I'm talking about the distance that forms a perpendicular angle with the other side. So I can't just draw it here, here. I got to make sure I can draw it so it makes a perpendicular angle with the opposite side. And I'm not even drawing the scale close. So it's got to be the perpendicular distance. You see what I mean there, Sophia?
So that way it ensures that all lines are
Correct, exactly. Because look, if I just say, hey, it's equidistant from the sides, you could go, all right, here's your incenter. So those two are equal because I drew them to the sides. No, absolutely not. They're not equal. It's got to be the perpendicular distance. And yes, that would ensure me that those lines are equal. What's up, Kyle?
Would it not have anything to do with midpoint?
No.
Okay.
Nope.
How would you draw that they're, would we have to draw the lines being perpendicular?
No, that should always be given to you. Okay, that'll be given to you. Any other questions, comments? Good job, guys. Good job. All right, go to the front of your packet because we have a number 2 to add on now, don't we? There's 4 total, by the way. I told you vocab was going to come strong. All right, what did we just find? What other set of lines are concurrent? Perpendicular bisectors, and you guys just found out? Angle bisectors. Angle bisectors are all concurrent at a point called the incenter. At a point called the incenter. And then, okay, what's our theorem about the incenter? Equidistant from the sides. Any issues? Because I'm going to do number 3 before we leave, too. I'm going to do the 3rd set of lines that are concurrent before we leave today. Anything you want to ask on the in-center angle bisectors? Hopefully I'm not going too fast. Anything? We good? All right. So let's go on to, we'll get back to that in a second, to write in number 3. I do want to introduce you to I don't know, is this a new vocabulary term to you guys? Altitude? Is that new? You guys you ever heard of the height of a triangle? That's another name for altitude. It's the height of a triangle. Okay, so maybe your teacher didn't use the word altitude. Maybe they said the height, but it is another name for height, is altitude. All right, here's what I'm going to drive home about an altitude. 2 things. It's got to start at a vertice. Every altitude starts at a vertice of the triangle. Second thing, it's always perpendicular to the opposite side. Starts at a vertice, perpendicular to the opposite side. Could you guys put any markings on your diagram? If you know that now, it starts at a vertice, perpendicular to the opposite side. Yeah, I see a bunch of people in class. I'm sure you guys at home. That's got to be a right angle then. Altitudes form right angles, yes. So conclusion, angle ADB and angle ADC are right angles. They have to start at a vertice and be perpendicular to the opposite side. Did I say it bisects the opposite side? No. No. It's just perpendicular. Maybe. You just know how to stop my steam, huh?
Well, I just want to know.
Yes, we are doing proofs in this unit, but not until the end. Okay, I want to get through all this vocab, and the proofs will not involve circumcenter and center, so don't worry about it. Okay, but yes, we are. They never leave, Meg. They never leave. Okay. Altitude. Everyone all right with what an altitude is? All right, honors kids. Prove to me you know what an altitude is. In any one triangle, how many altitudes exist? In any single triangle, like in my triangle up here, ABC, how many altitudes could I draw in? I just drew one in. How many total? 3, right? 1 coming from each vertice. Don't write this on your diagram, just focus in. So I got 1 coming from A, I'll have another one coming from C. Just pretend to me it's right angle, all right? Just pretend. And then I'll have another one coming from B. Any wild guesses what's going to be happening with all 3 altitudes when I draw them in? They're all going to be concurrent. Yes, all 3 altitudes in a triangle are concurrent. How about that, huh? All 3 altitudes. All right, well, what's the altitude's point of concurrency called? Anybody want to try to pronounce that bad boy right there, huh? Not the orthodontist. Close. Orthocenter, yes. That's the point of concurrency for all 3 altitudes. So now you know what an altitude is. There's 3 of them in every triangle, and they all intersect at the orthocenter. Hey, go to the front of your packet where we're keeping all these cheat sheet. We're keeping our cheat sheet. Ta. So what did we just learn now? We had perpendicular bisectors, angle bisectors, and now all 3 altitudes. Where do all 3 altitudes intersect? Orthocenter. Want a piece of good news? There's nothing special about it. I wish I could tell you there was, but there's nothing special about it. But, there's always a but, I do need you to know where it's located on a triangle, depending on what type of triangle I give you. So let's go back to the notes. You guys remember from last unit, you could name a triangle 3 ways based on its angle measure. based on its angle measure. Anybody remember one of three ways? How to name an angle based on its, not its sides, on its angles. Yes? Acute. So let's start with that one. If I had an acute triangle, where would my orthocenter be located? And I'll just use my diagram up above. That looks acute, right? All the angles look less than 90 there. That looks like an acute triangle, right? All right. Notice the orthocenter was located inside. Every acute triangle you have, all three altitudes will intersect inside the triangle. Inside. What other type of triangles did we have based on its angle measure? I had acute. Right. Yeah. You like how I did that? Anybody else see that? Never mind. Never mind.
I get it.
You got that?
Yeah.
It's like I can canoe. Anybody on that was pretty. That's always a good one. I can canoe. All right. Anyway, moving on. Moving on. That's a good one. Right triangle. Okay, here's a right triangle. Remember what an altitude was again? Starts at a what? Vertice and is perpendicular to the opposite side. Look at my right triangle I drew here. You guys see two altitudes without me even drawing a thing? Start from a vertice, perpendicular to the opposite side. Do you see two altitudes in my right triangle? Right there, and aren't these two altitudes? These two sides also altitudes. Starts at a vertice, perpendicular to the opposite side. Yeah, those are altitudes. And everyone see where they intersect? I don't need to draw the third one in. Everyone see where those two intersect? How can you say it's not inside, right? And it's not outside. It's on, right? It's on. Specifically, where on the triangle? Where the two hypotenuse.
Yeah, we're looking at hypotenuse because it's across from the right angle.
So it's where the two legs meet. Yep, where the two legs intersect. Okay, everyone see that? I just drew a dot right there on my right triangle where the orthocenter would be. Right? Everyone, okay, those are two altitudes. And then one final triangle. Oh, go ahead. Always for a right
also always be on the
always for orthocenter.
legs intersect and it's right.
Correct. Orthocenter only. I'm not talking circumcenter and incenter. I'm talking orthocenter only. Will be where the two legs meet. All right? Everyone else okay? And then there was one other type of triangle. I had acute, I had a right, I had an obtuse triangle. Okay, obtuse is a little bit different. All right, I drew an obtuse triangle up here next to the right triangle. Here's my problem, guys. I don't know if you guys have a solution, but if I drew an altitude from that vertice right there, is that going to form a right angle if I draw that line? Nah. Is that going to form a right angle if I draw that line? No, I got a problem. I cannot draw an altitude inside the triangle. Everyone see my diagram here? Where are some of my altitudes going to form? Be? Everyone see? It's going to be outside here. Outside. So where's the orthocenter going to be located in an obtuse triangle? Outside as well. All right, so for an obtuse triangle, it'll be outside, not obtuse again. So there's nothing special about it. I just need you to know where it's located. Question?
Never mind.
Okay. Everyone good? Okay. Hold on. Skip. I want you to skip one of the homework problems because it uses a term we haven't used yet. Skip number 25 tonight, everybody. Number 25 on the homework. Please skip it. It uses a vocabulary term we have yet to go over. So skip 25.
On which page?
And there's only 125. Okay. Good job, guys. Good job. Good work. Bring it again tomorrow for me. Bring it again.
Thank you.
All right, guys, bring it tomorrow again. Bye, guys. Bye, guys. Have a good one. See you, ladies.
Thank you. We have blackberries.
See you next week. This is a drill, right? This is a drill. Just show up after like 3 weeks off.
What are you talking about? I was in that Google Meets.
Yes, I did.
You gotta go see this bird park. This is in the park. Sorry. No, and I'm not gonna allow
I've
it.
talked to her, right?
I'm not gonna allow it.
You're not gonna allow it?
You haven't done a darn thing.
That is false.
Yeah, you tell me how it's false. I can show.
Because I have done stuff.
Bare minimum, like, how many assignments do you still owe from quarter one?
I mean, we're on to quarter 2 now, so we just have a strong next 3 quarters and be chilling for the
No.
year.
How many times you told me that too? I don't do the song, you don't do the song and dance with me. That works with other teachers, not with this guy. Okay? Not with this guy. The song and dance doesn't work and all the kind words and
No
everything.
song is no dance.
No, we've heard it before, bud. Not the place anymore.
Good morning.
Caroline?
Are you ready for yoga?
I did on third period.
Oh. Wait, weren't you in 6th period PE?
Mhm.
How'd that happen? Did you switch?
No, just
You have
both.
2 PE.
Yeah.
I forgot about that. That sucks.
I don't like it.
Are you graduating early?
I have no idea what to do. I've got 3 free periods in the day, and then I've got the 2 P's, and then I've got a couple classes next week.
That's interesting.
It's a schedule thing.
I have 3 art classes. So I have to take Pig and Econ next semester, back to back with Coughlin. Like, I don't like this class.
That's gonna be great.
He's my first period. He's good. I had him 9th grade.
His favorite assignments when they like don't have any meetings.
Yeah.
They just look a sign. And they're really
All we would do.
You guys got your calculator? You can get your calculator out. I'll get your packets.
Classroom assignment. We did take notes.
You guys at home, you should have packets. If not, it's up on Classroom. First thing, I'll let you know when your quizzes are.
Thank you.
Okay, here we go. Quiz number 1. It's all going to be given on the same day, no matter if you're going to be home or here. Okay, Friday, this next Friday, the 4th, December 4th. Friday, December 4th, quiz number 1. Okay? You guys that are in class right now, you'll be in class on that day, so you'll take it in class. You guys at home, you'll be home on that day, so you'll take it on formative with the side camera setup. You know the deal. Okay? Just the way things worked out, I had to give it. Well, actually, this is why I'm giving it all on one day, because I don't feel like giving a quiz on a Monday. Okay, I don't think that would have benefited you guys at home, the A through K last name, so I'm like coming in on Monday and taking it. So I didn't want to give a quiz on Monday. Quiz number 2 is going to be right before winter break. You guys in class, L through Z, last name's L through Z. I'll take it Tuesday, the 22nd of December. Tuesday, 12/22. You guys at home, A through K and remote students, you'll take it Wednesday, December 23rd. December 23rd is the last day of school before we go on break. So if you guys know you're going to be traveling somewhere, not being here that day, I want to get that quiz done before you leave for break. I do not want you to take it when you get back because it's not going to be pretty. All right? All good there? Have a calculator out, please, whether on your Chromebook or a handheld one. Make sure, I'll tell you that in a second. Just make sure you got your calculator out for me. Just make sure we're all doing what we need to do on our Chromebooks. Period 5. Okay, I know some of you guys are home that should have been in class today for whatever reason. So you guys wouldn't have a packet, so make sure you go to Classroom and download one right now so you can take the notes. Okay? All right, let's do this.